in this example, we're going to be looking at using z-scores to standardize test or exam scores in two different classes. We're going to be looking at a hypothetical class called Business Ethics with Dr. Who, and a class called Bioethics and Religion with Dr. Waverly. Let's say you took tests in both these classes right around the same time and just got your results back, and unfortunately neither of them are very good. Let's say that you went ahead and got a 59 in Dr. Waverly's class and a 74 in Dr. Who's class. While neither of these scores look promising, it's pretty evident that it looks like Dr. Who's score at least is a passing. So we might assume that we should be more proud of our score in Dr. Who's class and more ashamed of our score in Dr. Waverly's class. Let's look at why this might not actually be the right conclusion. To do this, we need some information about the exam scores in both classes. For Dr. Who's class, let's say that the average in that class was actually a 75 and that the standard deviation was right around 5. This tells us that on average people got 75, but there's a lot of spread going on. People might be a lot higher, people might be a lot lower as well. For Dr. Waverly's class, let's say that the average was actually 55 and the standard deviation, let's say, was 4. So right away we see that Dr. Waverly's class had a lower average and it also had a lower standard deviation, meaning people were more grouped together in this course. Once we have this information, we can go ahead and compare these two different test scores by standardizing them. That is by finding the z-score for each one. Now, in general, z-scores are always our observation, which we'll call x, minus our average, which is x bar, divided by our standard deviation, which for these is s, because these are samples. Once I know this, all I have to do is go ahead and find the z-score for both of these results. Over here, the z-score for Dr. Who's class will be x minus x bar over s, or 74 minus 75 over 5. This gives me negative 1 over 5, or negative 0.2. It's important to dissect this a little bit. First of all, I notice that z-score is 0.2. This tells me I'm pretty close to average. I'm only 0.2 standard deviations away. The other thing to notice is I have a negative in front. This negative tells me I'm actually below average. So I'm below average, but not by very much. Let's find the z-score for Dr. Waverly's class. To do this, I'll go ahead and I'll take my actual value x minus my average divided by my standard deviation, which will give me 59 minus 55 over 4, which is 4 over 4, or 1. This tells me I'm a full standard deviation away from average, which is kind of interesting because this says that I'm actually further from average getting a 59 on an average 55 test than getting a 74 on an average 75 test. So over here, I'm further from average than over here. The other thing to notice is that this is a positive one, and what that tells me is I'm one full standard deviation above average. This means that this score is actually better off, that I should be more proud of getting a 59 on an average 55 test than pulling a 74 on an average 75 test. I can tell that once again because my z-score over here is larger and positive, meaning I'm further from average and I'm above average. Compared over here, I'm pretty close to average and I'm also below it, so not the best.